Hello friends, let us now learn some important points about interaction of electron beam and the X-ray target. So in the last class we have learned about the X-ray tube, cathode, anode and um, different types of X-ray tubes we have seen and different modifications, anode Heal effect, and we have seen many things. Right now let us learn how X-rays are produced. So what is the mechanism of production of X-rays? So interaction of electron beam and X-ray tube target. So first we will see the atomic structure. First we should know what an atom is. There is a nucleus, there is proton. Nucleus will have protons plus neutrons. Around the nucleus there are electrons which are revolving around the nucleus like planets around the solar system. So the neutrons and protons will have a mass, and the mass of protons is equal to mass of neutrons, which is around 1.66 into 10 to the power of minus 24 grams. That means the electron is very lighter. It has less mass. So this mass of neutrons is around 1836 times the mass of the electron. Then let us learn some basics. Okay, atomic number is Z. So this atomic number is the number of protons in the nucleus. That means if we see hydrogen, it has one atomic number, so it has one proton. Helium, two atomic number, so it has two protons. Lithium, three atomic number, three protons, and so on. Then mass number is equal to number of protons and number of neutrons. So if you see the mass number of hydrogen, it is 1, so there are no neutrons. Whereas helium, the mass number is 4, so it has 2 protons and 2 neutrons. Lithium, the mass number is 6, it has 3 protons and 3 neutrons. So mass number is equal to the protons plus neutrons. Then what is isotopes? Isotopes are, it is the same element. Like for example, we have hydrogen. Hydrogen, the atomic number, because it is hydrogen, it is the same, but mass number might differ in an atom. So these elements, same element with same atomic number, same element with same atomic number, but different mass number. This is called as isotopes. Why are there different mass numbers? Because of protons. So if you see here in hydrogen, there are no neutrons because of neutrons. In hydrogen, there are no neutrons. H21, which is nothing but deuterium. In deuterium, there is two neutrons. Then H13 is actually protium. So this H13 is tertium, I think. So deuterium, tertium, it has three neutrons. So hydrogen atom 1, 2, 3 mass numbers. So this, as the neutrons increases, they have different neutrons, so they have different atomic mass. So what are isotopes? Isotopes is the same element with same atomic number but different mass numbers or different neutrons is called as isotopes. Then let us learn about electron orbits and electron shells. So this is the nucleus. Outside the nucleus, there are multiple shells are present or orbits are present outside the nucleus. And those orbits are named as K, L, M, N, O. And each orbit will have a limit for number of electrons. This is given by the formula 2n square. So for K shell, 2 into 1 square is equal to 2. So K shell will accommodate only 2 electrons. Whereas for L shell, K into N for L is 2. So K into 2 square is equal to 8. So L shell can accommodate 8 electrons, whereas M shell K into K 2 N square, 2 into M is 3, so 3 square, that is 18. So M shell can accommodate 18 electrons. Similarly, N shell can accommodate 32 electrons, whereas O shell can accommodate 50 electrons. And the diameter of the electron shells is determined by the force of the nucleus onto the atom and onto the electron, force of the nucleus on electron, energy of electron, and angular momentum of electron. So diameter of electron shells is determined by the nuclear force on electron, energy of electron, and angular momentum of electron. So one important thing that you have to learn about is the binding force. The binding force is the energy or the attraction between the proton and the electron. The force with which the electron attracts the proton is binding force. The force with which the electron attracts the proton is called as binding force. Binding force of electron is given by the formula, that is binding force of electron is inversely proportional to the distance between the nucleus and the electron square. If the distance between the nucleus and the electron increases, so the binding force will decrease. So here for the K shell electron, the distance between the proton and the electron is less when compared to L shell when compared to M shell. So this distance is less when compared to this distance and this distance. So K shell is the distance between the nucleus and electron is less for K shell, then N shell, then M shell, then N shell, then O shell. So because the binding force is inversely proportional to the distance between nucleus and electrons, so the binding force is more for the K shell, followed by L shell, then M shell, then N shell, then O shell. So you have to learn important about the binding force. Then we have to learn about the energy. Energy of either electron or proton or neutron, it has two different types of energy. One which is called as kinetic energy, the second which is called as potential energy. So bound particles like electrons will have negative energy. So it's actually they'll have negative energy. So to free from electron from the shell, the energy of the electron should be raised to either positive or zero value. So it has negative energy. So if we take an example of tungsten that is given by W, it has a negative energy of minus 70 kilo electron volts. So if we increase the energy of this electron to either zero or to the positive value, then the electron will be freed from the K shell. So binding energy is the energy that an electron in the shell must be given to increase the energy to zero. So binding energy is the energy that we have to give this electron so that the electron can free from its shell, that is to increase the energy to zero. So K shell have a binding energy of minus 70, L shell have a binding energy of minus 11 kilo electron volt. All these are negative values. You should remember that. So for example, for a transition, if an electron has to transit from L shell to K shell, L shell has an energy of minus 11, K shell has an energy of minus 70. So minus 11 to minus 70, so it is around 59 kilo electron volt X-ray photon is released when an electron transits or undergoes transition from L shell to K shell. So these are the important points, general important points about which one has to know before we deal with actual X-ray production or X-ray generation, which we will see in the next class. Thank you.